All right, so lesson 1.2. This one's going to concentrate on what are called simple random samples. So simple random sample. Sometimes you might see these referred to as an SRS. So a simple random sample of n measurements from a population is a subset selected in such a way that every sample of size whatever, from the population has an equal chance of being selected. So basically, everything in that population could possibly be picked is a simple random sample. So how do we get these? This example about selecting Toyotas, we're going to do in class. There's nothing really to write there. So if you move on, here's a vocabulary word. So a simulation is a numerical representation of a real-world phenomenon. And again, this example of tossing a fair coin, we're going to do in class. So what we're going to do is skip ahead to the different types of simple random samples. So when using random sampling, we want the sample to be unbiased and representative of the entire population. Now, unbiased means no favoritism one way or the other. This is kind of hard to do, so there's different ways that we can go about this. So just a basic sample would be, now I think this is a 10 by 10 grid that you're looking at. It would basically be really just randomly taking any of these and calling that your sample. So really, truly random. So the pros of this would be it is unbiased, it is representative, it's a natural thing to do in like the manufacturing business. You kind of just pick and choose. But some cons to it, to do very just a basic, simple random sample, it can be expensive depending on how large the population is and how many samples you're taking. Very time consuming. Because there's no real system in place, you kind of have to go it would just take a long time. You have to go all over the place within your population. And then again, depending on what you're doing, sometimes this can be geographically impossible. You just can't pick and choose randomly if we're spread out by hundreds and thousands of miles. So another type of simple random sample that we use is one called a convenience. So convenience sampling uses results or data that are conveniently or readily available. So it's almost like picking just, well, these people are close by, so that's who I'm going to sample from. The pros of this are that it's quick and cheap. But this can show bias. It's almost like self-selection. What that means is if I wanted to find out what the class wanted to do next and I only asked the people in the front row, I'm kind of self-selecting. I myself am picking who gets to answer. So that's not a good thing. So that's convenience sampling. It's used once in a while, but it's really not that good. It can lead to a lot of bias. So systematic is the next one. Systematic sampling is when the individuals in a population are arranged in some order. A starting point is picked, and then you select every, I wrote kth element for our sample. So every third, every fourth, every fifth. So for example, let's start with this one here, and then let's go every fourth one. So 1, 2, 3, 4, pick. 1, 2, 3, 4, pick. 1, 2, 3, 4. So maybe this wasn't a good one, but you can kind of see. Let me go back and how about this one? Let's try that again. Let's start here and pick every third. So 1, 2, 3, pick. 1, 2, 3, or however you want to do it. It's just every certain number that gets picked. And that's how systematic would work. So what are the pros of systematic? It's easy to implement, especially probably in a factory setting. And this is actually a good approximation of just doing it really, truly randomly. Cons, sometimes if there is a pattern in the data and you kind of pick the system that you're using and you happen to pick every silver Toyota that goes by, but there are other colors of Toyota. So if there's a pattern, patterns can cause problems. Okay, moving on. Another type of simple random sample is one called a cluster, and not that type of cluster. So cluster sampling is done by dividing the population into sections and then randomly selecting one or more of the sections or clusters. Every member of the cluster is included in that sample. So it's almost like taking these and saying, okay, I'm going to break them into, let's say, 5 groups, and I'm going to randomly pick these people and these people, or whatever you're talking about. So you break them into clusters, and then you randomly pick clusters, everyone in that cluster. So it's convenient and practical. Cons could be, depending on how things are arranged, the clusters can be different than the population. So it might not be representative, depending on how things are laid out. Okay, and I think there's one more, and this one's called stratified sampling. When groups or classes inside a population share a common characteristic and are broken up into at least 2 distinct groups, then a random sample of a certain size is drawn from each group, usually in proportion to the size of the group compared to the population. So to give you a rough idea of what we're talking about here, think of breaking this into, let's say, 4 pieces based on maybe geographical area or something like that. So we break these up, and then within each of these, we randomly select, maybe that's hard to see. Maybe this one, this one, this one, and then from here we take this one, 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 so that we have an equal number from each group or a proportion. Like if the red section was a little bigger, we would have to maybe select a few more individuals from that strata to make it more representative of the entire population. So the pros of this, it's a good representation of a simple random sample. The cons would be it's complex to pull off, and you need information about those individuals first so that you know how to break them into those different categories. So you'd actually need to know something about them first before you did that. And I believe that brings us to the end. Oh no, I'm sorry. There's a little bit more. I apologize for that. So a sampling frame is a list of individuals from which a sample is actually selected. So think like a class list. You could also call that a sampling frame. Undercoverage results from omitting population members from the sample frame. So, think of a class list, and I leave off maybe all of the males whose first names begin with M. Well, we're omitting population members from the sample frame. That's undercoverage. A sampling error is the difference between measurements from a sample and the corresponding measurements from the respective population. This is caused by the sample not being representative of the population. So basically, you picked a bad sample. And how you do that, there are various ways which we'll discuss later, how you can make those sampling errors. A non-sampling error is a result of poor sample design, sloppy data collection, faulty measuring instruments, bias in questionnaires, or other things like that. So there are ways that you can have error when you're taking samples, and we will talk about how we can avoid those and what to do if we do make those, and how we can actually use statistics and measurements to figure out how big of a deal that is. But that's down the line. So that is section 1.2. Let me know if you have any problems.